Hello everyone. I hope you all are doing great. So, welcome to again project related to Python. And in this project, we are going to learn very important concept. And this project can really make your life easy as a DevOps engineer. What this project is exactly going to do for us. So, as the title itself says, this project is for DevOps, Kubernetes DevOps automation. This Python script automates common DevOps tasks in a Kubernetes environment. It includes function to streamline operations such as load kubeconfig, means Kubernetes config file to load it so that you can make connectivity to your Kubernetes cluster. It will help you to list the namespaces and pods, and it will help you to display all the namespaces and then respective pods. That will help you to understand the current state of your cluster. Even using this, you can create a deployment. So it will help and it will simplify the process of deploying applications by programmatically creating deployments in your Kubernetes cluster. Delete a deployment. Even you can do the cleanup of your deployments. So adding in resource management and application lifecycle, you can handle this Python code to even delete the deployment. Check the health of pod. If you want to check the health of pod, you can even check the health of pod and you can monitor the status of pod using this code. So now let us go through the code line by line. First few lines we will be importing multiple libraries in our code. And what all libraries we will be using? First one is from Kubernetes import client and config. So what is this? This is the official Python client library for interacting with Kubernetes cluster. In this, will be importing client. So what this does? This module provide access to various Kubernetes API, allowing you to manage your resources like pod, deployment, services, etc. And config, this module is used to load your Kubernetes configurations, usually from a kubeconfig file, so that your script can authenticate and interact with Kubernetes API. From Kubernetes client.exceptions, import API exceptions. API exception, this is a specific exception class provided by Kubernetes client library. So this is again a Kubernetes client library which has API exception. It is raised when there are some error during API calls, like when you are trying to read a pod that does not exist, or there are some permission related problems. So catching this exception allow for better error handling in your code. Importing time. The time module provide various time related functions. It is commonly used for adding delay, example time dot sleep, or measuring elapsed time. Import random. Random module implements pseudo-random number generators. Like it will help you to generate random numbers. It is useful for generating random numbers or selecting random elements from a sequence. And import a string. The string module provides various string constants and utility functions. For instance, it contains predefined set of characters such as uppercase letter, lowercase letters, digits, etc. This can be useful when generating random strings. So now let us begin our code. First line we are importing Kubernetes module, and in that we are importing client and config. As I explained, client will help you to interact with Kubernetes APIs, and config to load the Kubernetes config file. And from Kubernetes client.exceptions, we are importing API exception so that it can help us to do better exception handling related to Kubernetes API. And time module, random module, and string module we are importing as well. Now we have multiple functions, but let us go to the main function and first understand how sequentially functions are getting called and what is the workflow. So if you go to the end of code, we have defined a main function. And in main function, First, we are calling the kubectl function. So load kubectl. What this function is doing on a high level? Help you to load the Kubernetes configurations so that you can interact to your Kubernetes cluster. Apart from that, there is a function called list namespace, which will help you to list all the namespaces, and listing a pod will help you to list all the pod in a particular namespace. And then we are using some function like time.sleep to sleep it for a few minutes. And then we have check pod health function, which takes the namespace and pod name as a argument, and this function will check the health of pod, and delete deployment function will help you to delete any deployments. So in the initial run, first we'll create some deployments and then later we'll delete the deployment. So I'm commenting delete deployment function. And here if you see, we have a create deployment function. So I am enabling this function. Now save this file. Now go to the beginning. So first function which we are calling is load kubectl function. What this function is doing? Config, you have imported already config here. So config dot has a function called load kubectl. This line calls the load kubectl method from config module of Kubernetes client library. Load the Kubernetes configuration from the default kubectl file, which is usually located at this location in most of the system. And then it will print a message like kubectl is loaded. And except if try is not able to do this, then it will raise a exception as E, and it will tell error loading kubectl, and then it will exit with exit value 1. Now, loading of kubectl is mandatory. Suppose in Windows system, if you want to check where your kubectl is stored, the path is generally this location. So here if you see, my kubectl is stored in this config file, and path is C users, user ID, and then .kube folder, our kubectl is stored. If you want to see the content of kubectl, you can check using notepad and then config. And you can see what is the content. This kubectl contains the certificate authority details, server details, which server and port my Kubernetes is running, and then context like which namespace is, so default namespace, and then cluster name is minikube. So these kind of informations are stored in this kubectl file. Now, once kubectl is loaded, you want to list the namespace. So for listing the namespace, you have a client.core v1 API. Creates an instance of core v1 API class from Kubernetes client library. So we are just creating an instance of core v1 API. So core v1 API class provide method to interact with various core resources in Kubernetes, including namespace, pod, service, and many more. So you are just creating a instance of core API and assigning it in v1. Now, what you are doing? You are assigning namespace is equal to v1.list namespaces. So v1.list namespace calls the list namespace method on the v1 client API client, and this purpose is this method retrieve a list of all namespace in your Kubernetes cluster. So now v1.list namespace will help you to list all the namespace in your Kubernetes cluster. Now we are writing a for loop. Namespace will have a list of items. So we are telling for ns in namespaces dot item. So it will iterate through each and every items in the namespace, and it will assign it in a variable ns. So what you are telling? Print, and f is format a string, which will exactly help the ns.metadata.name with the actual value. So what this is doing? This is telling metadata.name is actual namespace name is stored or printed here. You can see it is printed. And raising exception means if this one doesn't work, then it will raise exception and it will tell you that exception when listing the namespaces. Similar way, we have a different function, list pod, and for listing pod, of course, you have to pass a argument that is namespace. So list pod is defined to encapsulate the logic for listing pod in separate Kubernetes namespace. So client.core v1 API creates an instance of core API class from Kubernetes client library. I explained it before. And now again, you are creating an instance of this core v1 API library, and then you are printing listing the namespace. And after listing of namespace, you are doing v1.list namespace pod and then namespace. So what is list namespace pod? This is a method on the v1 API client parsing the specified namespace as a argument. So this is parsing the namespace as a argument. So here if you see, this is getting namespace as a argument and it is assigning its value into the pod. So it will list the pod. Now once you have the pod dot listed pods dot item, you put it into the pod and then you are printing the pod name and pod status and again raising an exception. Similar way, now you want to create a deployment. So for creating deployment, you need the namespace name, then name of that particular deployment, and then image, what version of image you are using or what is the name of image. So first you are again creating an instance of apps v1 API, and this line creates an instance of apps v1 API class from Kubernetes client library. This block defines a container using v1 container class. So again, we are defining a v1 container class here. So these are the different client libraries. Like you need the app name. So that is apps v1. This is getting using client library. It is getting apps v1 API. And then container name, client.v1 container is getting the container. And then you are passing the name of your deployment, which image you want to use, and then port, which port it will be running. So client.v1 container port, and container port by default I am putting here 80. And you need to provide the spec of your pod. Like when you create a deployment, you have to pass the spec. Spec is like how much resources you want to assign. So client.v1 pod spec, and it contains container is equal to exactly the list of container details. So this line creates a pod specification, v1 pod spec, that include the previously defined container. This creates a pod template specifications, and then in the down here we are defining client.v1 pod template specifications. So this create a pod template specification, set labels for the pod, allowing for easier identification and management, and spec is setting the pod specification that includes the container. So if you see v1 pod template spec, you are passing the metadata, and then label as app and name, and spec you are passing. And now then you want to create a deployment. So this creates a deployment specification, v1 deployment spec, and sets the desired replica, sets the desired number of replica. Selector, how to select the pod managed by deployment using levels. This is necessary for deployment to manage pods correctly. And template, this includes the pod template specification defined above. So in deployment spec, we are passing client.v1 deployment spec, and in this we are passing replicas is equal to 1, selector client.v1 level selector matching the level app name, and template again you are assigning to template. Now this creates the deployment object v1 deployment API version, specify the version for the deployment resource, kind, what kind of object, like it's a deployment pod, cron job or anything. Metadata sets the metadata of deployment including its name. Spec includes the deployment specification which is defined earlier. So in the deployment, client v1.deployment API version you are defining is apps v1, kind is deployment, metadata is actual metadata name, and then spec deployment spec function that will pass the specification details. Now this try block attempt to create the deployment in the specified namespace using create namespace deployment method. So if you see API response is equal to apps v1 create namespace deployment, and you are passing the namespace and then in the body as a deployment, and then you are printing deployment name, created a status and API response status, and exception it will raise, except API exception as is like error creating the deployment. Similar way, if you want to delete the deployment, you will pass define delete deployment function, and then in client dot apps v1 API again we are using the same one which we used before. Similar way, we will pass the parameters and other details, and foreground and other policies we are defining. And then here we are telling apps v1.delete namespace deployment, namespace name, body will contain the foreground, delete it, and then grace period is of 5 seconds. And then it will tell that your deployment has been deleted, else it will raise the exceptions. And now, if you want to get the pod name by deployment name, so you are passing namespace and deployment name. And now, obviously, you need the config. So config.load kubeconfig, and then v1 is equal to client.core v1 API you need to use, and then pod v1.list namespace pod, and then you are passing the namespace name, which will list all the pods belonging to that namespace. And then it will we have a variable matching pod, find the pod name starting with deployment name by iterating through all the pod names. So pod.metadata name for pod in pods.items, and if pod.metadata.name starts with deployment name, except it will raise the exceptions. And then to check the pod health, again core v1 API we are calling, and then printing, just I put print high, no need of this, and then printing the pod name, and in pod we are reading the namespace. So this overall purpose of this line is to fetch the details of a specific pod identified by its name, the first element of the pod name list within the specified namespace. So first element is 0, so first element and then namespace name. And a status, in a status it will put pod status phase and then print the status, and if a status is running, it will print a message that pod is running, else it will print that pod is in that particular state, and it will go to the exception in case, then it will print this message. Now, as I told, in the main function we are loading kubeconfig file, then defining namespace, default value we are putting the default namespace, then listing of namespace, and then listing of pod, and deployment name I want to create nginx deployment, and then image is nginx image. Suppose I want to create a deployment here, DevOps take a stack deployment, and then image is nginx latest, and then create deployment will get the namespace name, deployment name, and image name, and it will wait for 20 seconds for pod to initialize, and then it is calling the function get pod name by deployment name, and you are passing namespace and deployment name, and then it will print the pod's status for particular deployment name, and then it will give you the pod health. And in the last line of the code, if you see, this is exactly the starting point of the code, which is calling the main function. And in your main function, you are calling load kubeconfig and then another listing pod, listing namespace. So it will direct you to each function one by one. So now let us try to run this code and see how it is working. So if I go scroll up, just clear the screen and then run your Python code, and here I am running the Python code. So you see code is running. Initially I was having only guest book UI and all the namespace like Argo CD default, and this we are creating it into the default namespace. So everything should be done into default namespace. You can change the namespace accordingly. So now here you see pod is starting with DEVOPS-TECHSTACK deployment, and pod name is this, and let us go to the command prompt and verify. So if you do now kubectl get pods, you will see DEVOPS-TECHSTACK is started 36 seconds ago. If you do kubectl get deployments, you will see DEVOPS-TECHSTACK was created 47 seconds ago. Now, my next task is I want to delete the pod. So let us enable this delete function, and I don't want to create and run create and delete both at the same time. So I am commenting the create deployment function. Now let us run our code again and see how it is working. So now if you see DevOps Tech Stack deployment and guestbook UI was running these two pod in the default namespace. Now let us see what happens when this code execution is completed. Actually, what it should do, it should delete the DevOps Tech Stack deployment. So let us check the deployment again, and it is still running. Maybe it's taking some time. Now you see it has disappeared. So DevOps Tech Stack deployment has been gone. Now let us see pods are there or not. Of course, your pod is also gone. Only guestbook UI pod is available. So I hope you understood the code. See, in this code, we are importing the Kubernetes module, Python module, and those module has multiple, like for interacting with the client or loading the config file. Different modules are already created. We are just using those modules and then interacting to Kubernetes API to perform multiple operations like creating a pod, creating a deployment, deleting a deployment, listing of namespace. All these tasks are being performed using those defined libraries which is already available in Python. So I hope you guys got fair idea about the concepts like how to deal with your multiple deployments, life cycle management of the pod, and deal with each of these steps in the automated fashion. So thank you so much guys for giving your valuable time.